All right, all right. Hey, everyone. Hope everyone's doing great. I'm Luís. I'm a founder of MCPay, and we've been doing a lot of MCPay things. But for this talk, I want to talk a little bit about how we're trying to verify micropayments and the data that people get when they pay for things. Oops, sorry about that. All right, I think this will work. So our main product has been, we've been building this gateway. You can connect to the gateway, and under the hood, we're registering a bunch of MCP servers that are paid using X402, and the main goal is just to make it very simple for users to, just interact with MCP servers in general. You don't need to maintain multiple connections with just one. Ideally, you can get the data you want and pay for it. Over the past couple of weeks, since X402 hype is real, we got a bunch of transactions and new users and some USDC process. This is a very early project, by the way. Started at a hackathon many months ago, a couple of months ago, and we're very happy to share these metrics and to kind of show that what we've built works. But the problem is when people pay for things with X402, generally, there's no guarantees that the return data they get is authentic, it's fresh and tempered, and a lot of these things, right? I'm not a zk sort of, expert, but we're working with experts on this idea, and the idea we kind of had was what if we can attach zkTLS proofs to the paid responses, so we can give the user sort of a guarantee that the data they got is genuine, right? We're also thinking about this attestation. If some expert is in the room and wants to discuss this, I'm very happy to do it, because we want to make sure that we're doing this correct and right. But this matters because when you pay for things and you get, and I'm not sure, how many of you in the room have been using X402 or tried, or okay, awesome. Are you building with X402? Okay, one guy is building, nice. Awesome. But when people pay for these things, there's no guarantee that they make the payment, they get some data, but it doesn't mean that it's correct, right? If we can make sure that the data they get is correct, then we can build a lot of things on top of this, like a reputation system, on-chain refunding mechanisms, all these different things, right? So with vlayer, shout out to vlayer, Namita is there. They've been partners on this journey. And the goal is when an agent connects to our MCP proxy, the MCP proxy there, and they kind of there's a X402 payment handshake, there's a request through the vlayer notary to the end, the external resource. This zkTLS proof is generated with both the payment response, so there's a guarantee that the agent paid for this thing, and the data they got. So then we package this in the meta field of the MCP response, so the client gets both the data, the zkTLS proof, and well, they can then use that later on to prove that they actually got the data from the right resource, and so on and so forth. All right, this demo will be super short, but again, there's two things that are very important for this to work. When you connect to the MCP proxy, you set a header, for now, xvlayer enabled true. Then things happen, and in the end, there's a meta response. This does not pollute context. If you guys are familiar with MCP, this is just something that will not pollute context, but still agents and clients can still access the object. And there's a vlayer proof, and the next X402 payment response you can use to kind of validate this response. Okay, and then this demo won't work but I do have a demo here. I will play. This was recorded last night. And I'll stop while I'm actually, so this is one of the MCP servers we have on our registry. It's for Twitter API. Instead of paying $200 a month, you can use us. We're charging a few cents to access the API, just for read data, by the way. But the idea is you can connect using an API key, generate an API key, which I did here, copied the URL, and now I'm gonna head over to MCP Inspector. If you guys are building with MCPs, you already know this. This is how we test these things locally. Drop the URL there, and then set the vlayer header here, as you can see. And I'm going to try run one of these tools. I'm checking myself on Twitter. Give me a follow, by the way. And yes, so there's a vlayer, there's a response. Super quick, but you can see closely here, the payment response, the vlayer proof, and the actual data. And then in our Payments Explorer, you'll find the payment, how much was the blockchain, the chain, and then also some information we're showing here for the web proof. Yes, this is it. Oops, not this one. If you're interested in all of what I showed, as we have an SDK and a lot of things for developers to try out, docs.mcpay.tech/partner/vlayer. And I think this is it. Super short, super quick, but thank you. I have 8 minutes for questions. I'm not sure what you guys are going to ask, but let's do it. Anyone?
Hi, great presentation. So who's actually doing the payments in this case? Is user sending the payment, or is the vlayer responsible for sending payments to the X402 server?
Yes, that's a great question. So right now the setup I showed is we're using server wallets. So the user, when they create this API key, they kind of give us permissions to like execute the payment, but we proxy the request through the vlayer services. Yes, so like they are essentially a proxy of a proxy to the actual external resource. Yeah.
Was what we saw in the video real time, or because it seemed really fast?
It is very slow. This was cut. I added the video. I don't have internet. I would love to show, but it adds like maybe 20 to 30 seconds to each request when we enable the proof generation. Yes.
And just to ask additional question to this, are you running on Base, or which chain are you running on?
We do support all the EVMs that do have facilitators. Are you familiar with X402, right? So like the settlement for these payments happens on a facilitator. So like all the chains that do have public facilitators we support. So all EVMs, like most popular EVMs, like Base, can't remember on top of my head right now, but a few, like Avalanche, I guess, IoTex, never used, but it's there. And Solana, we do support Solana as well. Yeah, it adds up. It adds
that
up.
additional latency is not related to the blockchain. It's only related to the MCP computation.
The proof generation.
Proof generation.
Yes, yes. Yeah, exactly.
I also have a question. So you shown us how we can get a proof, the zk proof, that the server returned us back what we asked for?
Yeah.
And what happens if the server returns something else? The zk proof will show us that yes, the server returned something else?
Yes,
but the payment was already done, so the payment was already processed.
The payment is processed as you generate the proof. So
yes.
Okay.
But what can I do as a client? I send my money, I got back something I didn't ask for because the server was acting maliciously maybe, or there was downtime?
There's some compromise here, yes. Because like what you sent, when you ask for the proof generation, you actually send a signature. You don't send a payment. Basically, you're sending a signature that then will be sent to the external server or the resource, and the settlement only happens when the external server is after computes and settles the payment, then responds something back, and the proof is generated at that point with the payment proof that the payment response. Yes.
That's interesting. And how can this component, which is verifying the server's response, how does it know if they responded correctly or if I just got a whale service down page that Twitter was reporting, for example? Or like GitHub Unicorn, we are down.
That's a great question. We can discuss, maybe we can take a look at stuff. I don't know if I have the full context to answer that. All right, I think that's it. Thank you, guys.